Hello all, welcome to the course on Python programming for beginners. We are in Module 20, Lecture 2 on Pandas. In this session, we are going to discuss about indexing and slicing of data frames. First, let us discuss about the default indexing in data frames. Default indexing in data frames is based on integers and is auto-generated when we create a data frame if we don't specify any custom index. For example, here we are creating a data frame by using pd.dataframe and we are passing a dictionary which is data which is having three key value pairs. One is name and the other one is age and the third one is salary. So basically in our dictionary we have three different keys with four different values for each of the keys. So in effect we'll be having four different rows and each column is having four different set of values. And if you observe this data frame, this 0, 1, 2, 3 is the default generated index by Pandas. And we can access any of these rows by using the corresponding index. For example, df.ilock of 1. It is going to retrieve the row that is indexed as 1. So here the row that is indexed as 1 is name is Bob, age 32 and salary 60,000. So in this fashion we can access any of the rows of the data frame by using the default indexing. Next, let us look at the custom-based indexing in data frames. Custom indexing in Pandas data frames involves specifying our own indexing instead of using the default integer-based index. We can use a column name from the data frame as the index, or we can also provide an external index or a list or an array of values. So in this example, we are passing an index as the custom index with the index values as A, B, C and D. So if you try to create a data frame with the dictionary data as the data and the index which is the custom index, then the resultant data frame will be having the index values A, B, C and D instead of 0, 1, 2, 3 as we have seen in the previous example. Now, if you want to access any of these rows, we can do so by mentioning the indexing as the custom index rather than the integer based indexing. So, for accessing the second row where the name is Bob, we can access it by using df underscore custom dot loc of B. So, because B is the index here. Now let us look at the difference between label-based indexing and position-based indexing. In Pandas, indexing can be done in two main ways. One is the label-based indexing and the other one is the position-based indexing. So for label-based indexing, we'll be using LOC and for position-based indexing, we will be using ILOC. Label-based indexing is used when we want to select data based on the labels of the index and column names. And on the other hand, the position-based indexing is based on integer positions of the rows and columns. And this position-based indexing is used when we want to select the data based on the numerical index positions. So let us look at the two examples for label-based indexing and position-based indexing. In case of label-based indexing, we can access the rows 1 to 2 of our example data frame and also the columns name and age by using df.loc. And remember, for label-based indexing, we'll be using the function LOC, and for position-based indexing, we'll be using ILOC. Now let us see the same code by using the position based indexing. So here df.ilOC for rows will be mentioning 1:3, and for the columns name and age, since they are positioned at 0 and 1, we have to use the range 0:2. So here this 0:2 excludes the value 2, and it includes only the values 0 and 1. 0 stands for the column name and 1 stands for the column age. Next, let us see the Boolean indexing. And Boolean indexing in Pandas allows us to filter and select data based on specified conditions. We can use Boolean arrays to index data frames and keep only the rows that satisfy a given condition. For example, here we can use the Boolean indexing as df of age is greater than 30. Actually, this df of age greater than 30 is going to return a Boolean array where each row where the age value is greater than 30 will be true and all the other rows will be false. So in this case, out of the 4 rows, only the row that is labeled as 1 is mentioned as true. So only in this case, the age value is greater than 30. So if we pass this Boolean array as an index to the data frame, we'll be able to retrieve the corresponding rows wherever the Boolean array value results in true. Since here for the name Bob, the Boolean value is true, that is why it is going to retrieve only the row that is having the age value as greater than 30. Now let us see how to set a new index to a data frame. We can set a new index for a data frame using the set underscore index method. And setting a new index is useful when we want to use meaningful labels for our rows and perform more convenient label-based indexing operations. For example, here in this data frame, set underscore index name, that means the first argument is the name and in place equal to true. So this allows us to set one of the columns as the index. In this example, we are setting name itself as the index, and in place equal to true keeps all other values as true. And we can access each of these rows by using the corresponding labels. So df.loc of Bob, because here the name A has become the label, so we can access the row corresponding to Bob by using the label Bob. So df.loc of Bob, it is going to retrieve the second row. So in this way, instead of using the integer based index, we can set our own index by making one of the columns as an index. We can reset the index that is already being set in the previous part of the code by using a reset underscore index. And here again we have to pass the attribute in place equal to true, so which keeps the values intact. So previously we have changed the index as name, that means we made the name itself as the index. So after performing the reset underscore index uh, operation, the original integer index is being retained. Next we have the multi-level indexing, which is also called as the hierarchical indexing. and it is one of the powerful features in Pandas that allows us to work with complex data sets, and we can work on higher dimensional data by using the two-dimensional data frames. And in this, it involves having multiple levels of indices for rows as well as columns. Now let us see how the multi-level indexing works. Now let us consider an example where we are using the dictionary data with different keys, including employee, salary, years of service, city and department, having different values for each of these keys. For example, the key employee is having the values Rahul, Priya, Arav, Neha and Vikram with their corresponding salaries and their years of service of experience and the corresponding cities and the corresponding departments to which they belong to. So now let us create a data frame df equal to pd dot data frame by passing the dictionary as the argument. Now we can set the multi-level indexing by using df dot set underscore index. Here instead of one label we are passing two labels, city as well as a department. So in this way we can use multi-level indexing using two different columns. Now when we try to display the data frame with the multi-level indexing, let us see how it looks like. So here you can see this is the original data frame where we have five different columns: employee, salary, years of service, city and department. And when we applied the multi-level indexing, now the two columns city and department have become again the indexing for the new data frame. So city and department are the new multi-level index for the resultant data frame, having only the remaining three columns, which are employee, salary and years of service. Next, let us look at slicing. And slicing in Pandas data frames involves selecting a subset of rows or columns based on a specific criteria. We can use again the label based indexing by using LOC, or we can also use position based indexing by using ILOC or Boolean indexing for for applying slicing operation. Let us look at the example of the data frame pd dot data frame of data, where we have three different columns: name, age and salary, with four different rows having the indices 0, 1, 2 and 3. Now if we want to select the rows 1 and 2 whose labels are only 1 and 2, we can do so by using df of 1 colon 3. So this excludes the value 3 and it is going to retrieve only the rows 1 and 2. So that is why the result is having only the details of Bob and Charlie, which are the uh, first row and second column. That means the rows having the indices 1 and 2. Now let us see how to slice the columns. Since the columns are having the labels name, age and salary, we have to pass those labels as arguments for slicing the columns. So in this example, df of name comma age, remember here we have to use the two pairs of square brackets in order to specify the columns. So here we are selecting only the columns whose labels are name and age. So that is why the resultant data frame after slicing includes only the columns name and age, and it is excluding the salary column. Now let us see another example where we can slice both rows as well as columns together. So here df dot loc of 1 colon 3, that means we are interested in only the rows having the indices 1 and 2, 1, 2 and 3, and also the columns name and age. Remember, in case of ILOC, the last index is omitted, whereas in case of LOC, the last index is also included. So df.loc is going to include all the rows having the indices 1, 2 and 3 and the columns name and age. Next, let us see the label-based slicing, where the label-based slicing allows us to select rows and columns based on their labels. So here we have to use df.loc because we are using the labels. So here we are mentioning the rows by using the label range Bob to David. So it includes all the rows from Bob to David, including both these two rows. And also we are interested in having the columns age to salary. So since there are only two columns from age to salary, it is going to retrieve both the columns. So this is the resultant after applying slicing along the rows as well as columns. So it is going to retrieve only the rows from Bob to David and columns as age and salary. Next, let us observe the position-based slicing, and position-based slicing allows us to select rows and columns based on the integer positions. For example, here this is the original data frame having 4 rows and 2 columns, let us say. And if we apply the slicing if we apply the position based slicing by using df.iloc, here it includes the rows 1 and 2 and it excludes the row 3 because we are using ILOC. And once again, make a note of this. LOC includes the last value also, whereas ILOC excludes the last value. That is why 1 to 3 means it includes Bob and Charlie only. It excludes David because though it is having the label 3, it is, since we are using ILOC, it excludes David. And coming to the columns, here we are going to use the columns having the labels 0 and 1. So age is having the label 0 and salary is having the label 1. So it is going to retrieve both the columns. So in the resultant data frame, we'll be having the rows 1 and 2 and the columns 0 and 1. Because in ILOC we will be excluding the last values for the rows as well as the columns. With this we came to the end of this session, and now let us look at the quick summary of this session. Indexing in Pandas data frames involves selecting specific rows and columns based on labels or positions, and custom indexing allows us to use meaningful labels as indices, and we can use label based indexing using LOC for selecting data based on labels, whereas position based indexing is used for integer based indexing, uh, during which we have to use the function ILOC. Boolean indexing enables filtering of rows based on specific conditions. Slicing in data frames involves extracting subsets of data using various methods, allowing for precise data manipulation and analysis in Pandas. And thank you for joining me in this session of indexing and slicing in Pandas data frames. And we have covered the essentials required for effective data manipulation in Pandas. And I encourage you to practice whatever we have learned during these sessions of Python programming for beginners. Thank you.